right, I'm going to get started. So I'm Dhruv Tukral. I'm a solutions architect for gaming here at Amazon Web Services. And today I'm joined by Tara Walker, who is a technical evangelist also at Amazon Web Services. We thank you for your time for coming today. The topic for our presentation today is build and deploy your mobile game with AWS. Click. Next. There you go. So what does this picture have to do with today's presentation? I know it's lunchtime. I hope everyone's eaten. If not, I apologize for showing this picture. But just hear me out for a second. Today I want to talk about table stakes for your game. So that was a table full of stakes. I know it's a lame pun and deserves its own lame pun-coon. So, I'll put it in there. But in all seriousness, I want to talk about all the services that are considered standard offerings than just your mobile game itself. Things that customers expect from your mobile game, which is not just your gameplay itself. So the first thing is, obviously, you want to be able to authenticate users. Every game is about acquiring and keeping players and keeping them within their ecosystem. And so when players come into your game, you want to give them the flexibility to be able to register from as many authentication systems as possible. You don't want to have any friction to adoption. Then, once you authenticate those users, you want to be able to authorize access to the different features of your game for your users. Chances are, when you give them access, they'll have elevated access to different AWS resources, such as your DynamoDB tables, perhaps your S3 buckets, perhaps your Kinesis streams, and so you want to be able to manage access to those AWS resources. And then you want to be able to synchronize data. A lot of players these days play games on multiple devices. Many households have iPhones and iPads, Galaxy tablets and Galaxy phones. A player might start playing your game on an iPhone and then move on to the iPad, and they would like to have the same seamless experience and do not have a break in continuity. You then want to store and deliver media. Downloadable content is very critical to the mobile gaming ecosystem. Also, a lot of times, your initial build is actually pretty small to keep that over-the-air download size pretty small. And so when your game first starts, in the background, you just start downloading assets, whereas when the player's playing the first level. And so you want to do all of that transparently, and you don't want to be focusing on managing the back-end storage of it. And then you want to analyze user behavior. This is critical. I work with a pretty big mobile gaming customer, and they told me that they consider themselves a 70% mobile analytics company and a 30% gaming company. Now, whether you agree with that philosophy or not, the one thing that we can agree upon is analytics is very core to mobile gaming. In fact, any kind of gaming these days. And then you want to be able to interact with your users. Oftentimes, you leverage the results that you get from analytics, and then you combine that with push notifications, and then you want to send push notifications out to your different users. Maybe you want to inform them of new downloadable content. Maybe you want to inform them of new updates. If there are challenges between friends, you want to be able to inform them of about those events. And you want to keep players engaged. You want them to keep coming back. You want to have that back and forth communication with them. And then finally, you want to store shared data. Features like leaderboards, achievements, high scores, all involve a central back-end storage where you can perform all this functionality. And more often than not, you're responsible for managing that back-end storage. NoSQL solutions are really good because they provide high throughput, low latency. We see everywhere from like MongoDB to DynamoDB, lots of NoSQL solutions used by gaming companies out there. And so I would like to introduce the AWS mobile services offerings that we have. We have a full range of services that supports all of this functionality, and they're fully integrated with the rest of the AWS offering. And they're optimized for mobile use cases. On the top of the stack is your mobile app, game, or device. And then within that, we have your mobile SDK, your API endpoints. We actually provide native SDKs for iOS, Android, as well as Unity. And so we have access to, you have access for cross-platform development as well as native development. And then what about the other features that I just talked about? What you see is for authorization and cross-device sync, you have Cognito. And Cognito allows you to provide support for various authentication providers, provide support for cross-device sync. For analytics, we have mobile analytics, which allows you to support the most commonly requested analytics features right outside the box. We have a very powerful cross-platform push notification service in SNS that supports various push notification gateways. And then we have a Kinesis recorder that allows you to send data to Kinesis streams. We have a DynamoDB mapper, which allows you to access DynamoDB tables very easily. And then we have an S3 transfer manager, an SQS client, and SES client. And so we have all these connectors within our AWS mobile SDK. And I'm going to be talking about these bits and pieces in a little bit. So I want to start out with Amazon Cognito. Cognito provides three major benefits. The first big benefit is ability to provide cross-device sync operations. And so natively, your players can play games across different devices. When using Cognito Sync, you're able to have that seamless experience for stored user data. Cognito manages the synchronization of that data set for you. Secondly, Cognito provides you out-of-the-box support for third-party authentication providers via Facebook, Google, Amazon. You can have your own developer backend authentication system that you can integrate with Cognito. And then finally, for providing a sneak peek, some kind of initial access to your games, we also support guest users. And so a lot of times people come in to play a game, you give them a first level, and then you tell them to register the game so they can get access to the next levels. So Cognito supports guest access, and then converting that guest to an authorized, authenticated user, it supports that transition as well. And then finally, Cognito allows you to implement security best practices by not exposing your AWS service credentials. You don't want to embed those credentials within your app. And so getting started with Cognito is pretty simple. You sign up for an AWS account, you log into your management console, and then you create an identity pool for authenticated and unauthenticated users. An identity pool is the highest level construct, and it essentially is a collection of users. And then you download and integrate the mobile SDK and store and sync that user data in a data set. So I'm going to go through an actual demonstration of how to go about this. Let's escape this. Oh, whoops. Oh boy, everything's going to launch right now. That's awesome. All right, let's see. Oh, there it is. Please be already logged in so I don't have to. Yay. All right, let's see. So I already have a few identity pools. Oh, I should have deleted this. I'm going to create a new identity pool. And I'm going to call my game my retirement plan 2, which is what we all hope. And then to enable guest access, you actually have to specify that setting. And so you enable access to unauthenticated identities. Let's see, where's my notes? So in the case of supporting public identity providers, you want to be able to register those apps with those identity providers. And in this case, I've already done this for my application. So you go here. This is for Amazon. They will provide you with an app ID. In this case, I've done it for all 3 platforms. If you have your own developer authentication system, you want to create a tag so Cognito can uniquely recognize your backend authentication system. And so in this case, login.amazon.myretirementplan2. And then basically you create a pool. The next step goes into the security aspect. So what you'll see is there's 2 sections for IAM roles. And what this allows you to do is create a tier of users wherein authenticated users can have a separate role. In this case, I've already created a role for a different game. And so what it allows you to do is you can tell Cognito that for all my authorized users, please give them access to this DynamoDB table, this S3 bucket, and you create that tier system. Whereas for your unauthenticated identities, In this case, I have created another role, which basically says that for all unauthenticated users, you only give them access to this temporary bucket. I don't want them accessing my database because obviously, it costs you money. And so when they register, they get elevated to an authenticated user, and you update those roles. And then you are provided with code that you can just kind of copy, paste, and start integrating within your application. We have sample code for Android, iOS, JavaScript, Unity, .NET, you name it. And essentially, you copy paste this. You have the Cognito constructor where you pass in the identity pool ID that you just got. In this case, it's already pre-filled for you. And then the region where you created that identity pool in. So let's go back to... So I wanted to give you an overview and kind of a behind the scenes of how the security model works within Cognito. As I mentioned, there's two authenticated identity providers. There's the third party, in which case your user connects to Facebook or Google or Amazon. They log in. Upon successful authentication, Facebook, Google, or Amazon returns an OAuth or an OpenID token back to your application. You then send that access token, the pool that you created, and the different IAM roles to the Cognito identity broker, which in turn actually returns a Cognito ID for your user and a set of temporary credentials. And then you use those credentials to access the different AWS services. For developer authenticated identities, the flow is a little bit different. Your user connects to the user authentication system, which is your own authentication system. And so you say yay or nay. In case of yay, you connect to the Cognito identity broker. You say, I trust this guy. Trust me, take my word for it. Cognito identity broker says, OK, I'll listen to you. I'll send you back an OpenID token. Your authentication system then needs to return that OpenID token back to your application. And then your application, via Cognito, will transport that same OpenID token with the pool ID and the resource ARNs to the Cognito identity broker. And then you get the Cognito ID, and you get the temporary set of credentials. And then you basically access the features and the resources as you would beforehand. So I want to give an example of a company, a mobile gaming company that uses Cognito. Concrete Software is a game developer. They leverage Cognito so they don't have to maintain and manage their own authentication backend. They're also very heavy users of Cognito Sync, and so they don't have to worry about provisioning storage or writing custom logic on managing cross-device sync between the different devices. And so their customers have a very seamless experience. So talking about synchronization of data, Cognito also provides you with the ability to sync app data. It stores app data, preferences, and state for you and automatically syncs that on the back end for you. It provides offline mode so users can keep playing your application, and then when the application connects online, the data set automatically gets synced. It will manage conflict resolution for you. By default, the last write wins, but you have a callback mechanism. So in case you want to have custom logic to handle the synchronization, there's a callback where you can write your own code to manage conflicts if you choose to do so. And then integrating Cognito Sync functionality is very simple. You initialize the constructor. You provide that Cognito pool ID that you just created. You choose the region where that sync data is going to be stored, and then you choose the provider. And then creating a data set is very, very simple. You open a data set. Each data set can be up to 1 megabyte in size. It is a set of key value pairs. And then you call the synchronize method. And within the synchronize method, there's a sync callback where, as I said, you can write custom code to manage how you want to handle the sync operations. Here's some sample code for iOS. And then we also have sample code on the AWS Mobile SDK website for different platforms. So don't feel that you've kind of lost out. There's all of this code available for you online as well. So next, we want to focus on storing and delivering media assets via S3 and CloudFront. For that, we actually provide an S3 connector called the Transfer Manager. And what the Transfer Manager does for you is it handles multi-part upload for you automatically. And so you don't have to worry about breaking your file into multiple chunks and then creating multiple parallel threads to do uploads. All you have to do is make a simple function call, pass in the file name, and Cognito abstracts that, the S3 Transfer Manager abstracts that for you automatically. Downloads are fault tolerant, so you can resume downloads without having to keep a track of byte range requests or the amount of file size that has been downloaded. Everything is seamless. There's no backend required. You connect directly to S3. It supports automatic retries. You can pause, resume, and cancel functions. And the code is optimized for the different native OS SDKs that you will use. So in this case, there's some sample code. As you can see, uploading a file is as simple as calling an upload file function. Downloading a file is called download file. And then you have native support for pausing transfers, resuming transfers, and canceling transfers. And just like I mentioned for the previous part, all this code is available on the AWS Mobile SDK website as well as our GitHub. And so another customer that uses this heavily is Outplay Entertainment. The challenge that they had was they wanted players to start playing their games quickly, and so they wanted the OTA file size to be really, really small. And what they would do is the file size would be small, players would start playing the game, and in the background they would leverage S3 Transfer Manager to download the other levels. And so they stripped out everything that they didn't require and just kept it to a bare minimum build, and then everything was downloaded on the fly depending on how far the users got into the game. Next step is analyzing user behavior. And for that, we provide Amazon Mobile Analytics. There's three major advantages to using mobile analytics. First of all, it measures the most commonly measured metrics automatically for you. You don't have to write any custom logic to measure events like daily active users, monthly active users. I'll go over the different metrics that we support. It has a very generous free tier. You can get up to 100 million free events per month, and every 1 million events right after that is $1. If you are reaching that scale, then we hope you share some of that money with us. But still, to get started out, 100 million events is quite a bit. And finally, the big plus point for me is you actually own your data. All the data that is being stored in mobile analytics, you can export it out, and then you can ingest it in your processing and visualization tool of choice at any point in time. So you have access to all your data. You own the data that is being stored for this feature. And so getting started with mobile analytics is, again, pretty simple. You sign up, you create an AWS account, you use the existing Cognito ID, you download and integrate the mobile SDK, and then you view engagement and session activity in the AWS console within minutes of integrating your application. So I wanted to show you what the mobile console, the analytics console looks like. We support out of the box, monthly active users, daily active users, new users, sessions, sticky factor, ARPU. So monetization and growth metrics, things that are really important to you to get started out, comes enabled right outside the box. What we also provide is the ability to track custom events. In case you want to measure something that is not provided out of the box, you can put in custom events. Say if you want to measure how many people reached, how many players reached a particular level, or how many players downloaded a particular piece of downloadable content. You can start using custom events to put that data into mobile analytics, and you can create your own customized reports for yourself. And so, same sample code. The thing that is of interest here is for custom events, you create a specific mobile analytics event, and then you provide the value, and then you start recording that event. And so you can just kind of create multiple event types and start sending that data over to the AWS Mobile Analytics through the SDKs. There's some sample code for iOS as well. So now that you have mobile analytics, what do you do about sending push notifications? In my past life, when I worked at Electronic Arts, I actually wrote the push notification platform that supported the different games. And I think by the time I was done, I had worked on iOS and Android support, which felt like quite a feat. But it is a lot of heavy lifting because you have to worry about managing push tokens. You have to worry about what if the push notification gateway changes make some changes. You have to update your code. You have to manage all of that. And then we had a fleet of EC2 instances that was responsible for sending out push notifications to different customers. And so we had to manage and maintain and scale those instances every time marketing sent out like a push notification event. With SNS Mobile Push, you really don't have to worry about any of that. It's very abstract. In fact, you just connect with the service directly from your SDK. Right now, we support Apple, Google, Baidu in China, which is, I think, we're the first, Amazon, and Windows right outside the box. You don't have to write custom logic for each of these gateway providers. We do that for you. On top of that, we're constantly adding new features for SNS. We have a message expiration time. Let's say you want to send out a push notification for a downloadable content for Christmas. You want to make sure that that message expires after December the 25th. And so we have support for that. We provide message attributes that your application, if they want to read it, the application can read it. We provide delivery status. There's a difference between delivery status and delivery confirmation. Delivery status actually provides you the state of your push notification request in the SNS system itself. And so if you want to query whether SNS has already sent out the push notification via the gateway, you can do that. It's not delivery confirmation just yet. We support broadcasts via SNS topics. What it allows you to do is allows you to create a set of users that you can send out push notifications to. Let's say you want to send out a push notification to all users in the UK. You create a topic, and you register all the users with that topic, and then at the push of a button, you just send a push notification to that topic, and then it automatically broadcasts that message to multiple users. And each topic can support up to millions and millions of users on a per topic basis. And then we just added iOS 8 support. So that's something that you didn't have to do yourself. Storing shared data. How many folks here know about DynamoDB? Raise your hand. Okay, so I will go over this because this is exciting. DynamoDB is a fully managed NoSQL solution. What it allows you as a developer to do is you don't have to worry about scaling the backend infrastructure if you're using a NoSQL database. All you end up doing is providing DynamoDB with the throughput. Oh, whoops, sorry. This is too close to me. With the throughput that you need for reads and writes, and on the back end, DynamoDB manages that scale for you automatically. And so it's fully managed. You don't have to worry about scaling. You don't have to worry about provisioning hardware. It does all of that for you automatically. It has a very simple API interface. It supports JSON documents. It has a very rich and ever-growing query interface. Definitely encourage you guys to check it out. In our case, for the mobile-specific use case, we provide an object mapper. And what the object mapper allows you to do is you don't have to worry about mapping your objects to a table, a DynamoDB table. If you guys are familiar with ORMs such as Hibernate, this is exactly what it is. So you don't have to worry about reading from DynamoDB, converting it into an object. It just does that for you natively. So in this case, we have a high scores table with the user ID, the username, their high score, and you map that to a class. So the annotations maps that class to the table. You create getter and setter methods. You have those annotations, and then you can just get started. So in this case, you build a new high score object. You populate it with data, and then you just call mapper.save. If you want to update that object, you basically change the values. Click on mapper.save. If you want to load another object, you basically pass in the class into the function call, and then the value, in this case, the user ID, and then you can start modifying data. And so we also have sample code for all of this. Some best practices for DynamoDB. You want to keep your item size small. If your DynamoDB item size gets really big, what we suggest is you break it down into storing just the metadata parts onto DynamoDB and all the blob data into S3, when your metadata has linked to the S3 URL, because storage is expensive. DynamoDB runs on SSDs. It's really fast, has very high throughput. So storage is, and you want to save on storage. So that's one way that you can store. You can save on storage costs. Use a table with a hash key for extremely high scale, so you can do easy queries. For time series data, we recommend, because it's so easy to create and drop tables within DynamoDB through an API call. If you're just storing information on like how many people downloaded particular downloadable content in a particular week. You create a time series table, you calculate, you aggregate all that data, send it to your data warehouse, and then you just delete that table. You save on storage. It's very easy to do. You just keep creating tables on a time frame basis. And then conditional updates. This is a very useful feature. If you're looking to, if there's, especially in the case of cross-device usage, if someone's trying to cheat your system, wherein a person is playing the game on an iOS device and on an iPhone and an iPad, and let's say they're trying to add gold to the backend. Let's say I have 500 gold, and on my iPhone and iPad I purchase both of those at the same time. Usually, if you do not use conditional updates, for this, if those requests come in almost simultaneously, you'll end up getting 500 plus 100 plus 100 gold. But if you use conditional updates wherein you say only add gold if the value within the database is 500, then it will reject the second call. And so in that case, whichever device is able to make the call first will be able to, the user will still be able to get their 100 coin, but they'll not be able to get twice as much because you put that condition in there. And then you want to avoid hotkeys and hot partitions. On the back end, DynamoDB splits your data across partitions. And so let's say if you have a user that is using DynamoDB quite a bit, it really becomes an atomic construct. You cannot break that user into more partitions unless you start appending prefixes or suffixes. Best to avoid, hotkeys. We have, a specialist essays that help you look at your DynamoDB tables, and so they can give you best practices around schema designs and access patterns. So you have all this functionality that comes, already available with the AWS Mobile SDK. But what if you still have some kind of backend processing that you want to do? What if you still want to add some kind of server backend? Well, thanks, Firefox. Thank you. That is very important. Oh, it crashed my PowerPoint too. That's awesome.
Oh, nice. Congratulations.
Yay, yay. All right, where's my downloads?
Now official.
I should have updated my Firefox. Please bear with me while we have some technical difficulties. Let's see. Okay. Apologies. This is a reminder to update your Firefox if you haven't done so already. Whoops. So if you do want to create your own backend, there's 3 ways to do it. You can choose to do it yourself. In this case, I have a very basic Hello World stack when your clients are connecting to your backend service through the Elastic Load Balancer, which is distributing traffic to your web and app instances, which are running on EC2, and they're in separate availability zones. For your persistence, you have MySQL running in RDS, running in multi-AZ configuration. What that allows you to do is, in case the master goes down, the slave gets promoted automatically through a quick DNS switchover, and you don't have to change your application code. And so you have high availability in this particular architecture. And for your assets, you basically just connect to S3. You can do that directly with the S3 Transfer Manager. You don't have to actually go to the backend. If you want to scale it out, you start adding your web or app tier to an auto-scaling group. And you can use CloudWatch along with ELB, and you can choose how to scale this. You can choose to scale this via custom metrics. So if you choose to scale this based on the amount of users that are actually connected to your app servers, you can choose to do so in that way. Or you can choose to scale based on the standard metrics that come with CloudWatch, such as CPU usage. If there's a lot of writes and reads coming through, you add a caching layer. We have Elasticache that supports Memcache and Redis. And if you want to offload some of the read-heavy stuff away from the database tier. And then as your game grows, as you get more players from across the globe, you want to make sure that the content is close to them. Whoops. And so you push that content via a CDN called CloudFront. It's pay as you go, no long-term contracts. You just integrate with S3, and you basically have global reach for your users. The other way you can do this is you can do something which is fully managed, which is our Elastic Beanstalk solution. It's a very popular managed container service that supports major platforms like Java, .NET, PHP. And what it does for you is it creates those resources for you. And so when you start like Elastic Beanstalk Java container, it will create the ELB for you. It will create the EC2 instances. It will register those instances with the ELB. It will create the RDS instances. And all you have to do is, if it's a Java, framework, you have your WAR file. You push that WAR file to Elastic Beanstalk, and it will deploy that WAR file across all the EC2 instances. Comes with a dashboard where you can monitor the health of all your architecture, and it has the same performance because underneath it is the same infrastructure. It is just fully managed for you, so there's no overhead. It's a free service. You only pay for the resources that you're using, and so a lot of mobile developers leverage this. It's very easy and a quick way to get started. Or you can go serverless, which to me hurts me because I'm a back-end engineer, and so I have to learn this new paradigm. And I want to talk a little bit about Lambda. We just announced Lambda in last year's reInvent, and what Lambda is it allows you to run stateless cloud functions in the cloud. What that means is you just write your code, and you give that code to Lambda, and Lambda manages the execution of that code for you. You don't have to do anything. You don't have to set up databases. You don't have to set up storage. You don't have to set up like any kind of compute. You just push that function out to Lambda. To define Lambda, I want to break this definition down. Lambda is essentially an event-driven asynchronous code execution platform. And so if you break this down, you'll get a full understanding of what Lambda actually is. What I mean by event-driven, it means Lambda executes code on an event. This event could be sourced from an AWS service, or it could be sourced by you. You can manually execute a Lambda function. Right now, we support custom events. We support S3 notifications. So if there's a change to your S3 bucket, you can invoke a Lambda function. Any changes to your DynamoDB tables can invoke a Lambda function. And then Lambda functions can listen to Kinesis streams and process data coming in from Kinesis streams. How do you invoke a Lambda function specifically? You can invoke it on a Lambda console. If you're trying to do this manually, you can go to Lambda's console, copy paste your function, and then just click on run that function. You can use our SDK or CLI to call invoke sync. We expose these methods through our SDK and our command line interface. Or by registering an event. And I already told you, right now we support S3, DynamoDB, and Kinesis. Lambda does not have native scheduling support. So you can hack around it by creating cron jobs. So it is kind of cron-ish, where you can, like, in a cron job, keep calling the Lambda function, but there's no native support just yet. I know it's a highly requested feature, so we'll see how that goes along. There's no support for remote procedure calls, and you cannot invoke a Lambda function to the REST interface. So what do you mean by asynchronous? What it means is a call to Lambda function is non-blocking. So it's not your typical request response. When you call a Lambda function, it returns immediately. You do not wait for an answer. You just assume your function is going to execute, and your request is going to be processed. If you do want some kind of notification, your Lambda function can call an SNS topic or SNS notification, and then you can listen for those SNS notifications. And then finally, the code execution platform. The underlying infrastructure is entirely managed for you. It supports Node.js only right now, but there are more languages that are in the pipeline. Runs on Amazon Linux, and provides up to 500 megabytes of temporary storage, which means you cannot share persistent state across different executions of a Lambda function. It's atomic, and so it runs self-contained. And then once it finishes running, then you lose that persistent state. So now that you have all these options, let's focus on scaling it a little bit out more by adding some decoupling. You can do this via messages, and so I've already talked a little bit about SNS, and so your previous stack that I just talked about, your Hello World stack, can send notifications to your user either through SMS, push notifications, email, or HTTP notifications. In the case of background tasks, such as if you're doing avatar resizing, you can add some more decoupling by putting in a SQS queue in there. And so what happens is, let's say user uploads some images to your backend. You push messages to an SQS queue. There's a list of worker nodes listening for messages on that SQS queue, and they start processing data. And then once they're done processing, they send a notification back through SNS back to the user, and then the user gets notified that their avatar has been resized. And so now I would like to pass the stage on to Tara, who has some really exciting, fun stuff for us as well.
Is that setting me up? I don't think so.
No. There's no pressure. Thanks, everyone.
Okay, I have to lower this. All right. All right, so I know it's after lunch. Please wake up. I don't want to have to point any of you all out. I will. And note that you're sleeping, so you'll be on blast for everyone. So he talked about such great things. That's wonderful. He set it up perfectly for me. Now, how do we implement this? So AWS Mobile SDKs, there are 3 of them, as he mentioned, and these are, of course, you built your game for them. There is the AWS Mobile for Android. He talked about that. There's the AWS Mobile SDK for iOS. But what I'm not sure if you guys know about is that there is a third. So what I want to talk about today, and I'm very excited to announce if you guys didn't know about it, is introducing the AWS SDK for Unity. So let's talk about how you get started with that. I know you guys are familiar with Unity, and so we're really excited to offer this to you. The first thing you need to do, obviously, is download the Unity SDK. The URL is there. Don't worry. Our slides will be available for you. You're going to import some desired packages from AWS services that you want. So what's the packages that we have? We have the Cognito Sync package. He told you the goodness that's involved in Cognito Sync. We have the DynamoDB, S3, and the Mobile Analytics package. So you can mix and match, take all of them in, or do what you desire, but these are available for you. And the only step that you have left to do to make sure you have the great AWS services in your Unity game is then to add the AWS prefab to Unity. So the demo, of course, I have to hope the demo guys are kind to me, will showcase Cognito Identity, Cognito Sync, and we'll talk about the mobile analytics. Now, this demo is going to be open source, but give us a little time. It needs a little polish. It needs to be cleaned up a little bit. You don't need to see my little notes to myself, like, why did you do that? So we're going to clean that up. And then we'll actually add some more AWS services to this demo. However, if you cannot wait, there are plenty of samples out on the GitHub. If you go look for our AWS Unity samples for you to download and leverage, you don't have time to wait for me to clean up those comments. All right, so let's talk about actually setting this up and doing this. So mobile SDK, the service is set up. So the first thing I need to do, got to follow his advice, right? I'm going to go set up a Cognito identity pool. I'm going to go set up mobile analytics, but we're going to set it up for my game. Well, really, I'm not going to set it up, kind of already did it. So let me show it to you. And I just need to switch this over to, All right, so I go to this browser over here. You'll see, obviously, I love Cognito because I have a bunch of different apps using it. But the one we're going to leverage today is the Grumpy Flappy game. Yes, it's called Grumpy Flappy because I couldn't think of a better name. Everything else is taken. So that's the name of my identity pool. You'll see as I've been testing and we've been playing around with it, I have 69 identities set up so far. We've synced 126 data sets. And right now I'm only using unauthenticated, only because I'm rendering this in the web, so the web player, so Facebook doesn't play kindly with that. All right, so if you look at my identity browser then, you can then see all of the great identities we created with this. So you know how to do the steps. I have my identity pool. I'm ready. All I need at this point is the identity pool's ID. So all I would need to do is make sure that that identity pool is going to get into my code. I'm going to show you the code in a minute. What's the second setup I have to do? I said mobile analytics. So I'm going to go back to my browser. I already have it up, of course. And then all I would need to do is just set up a mobile analytics app. So you see here, add app. You see I've already done that. Grumpy Flappy is there. So I'm ready to go. So let's now go into Unity. Voila, Unity is there. So the third step I said was to add the AWS prefab. Guess what? That's there, AWS prefab. Now the AWS scripts, that's mine, just because I decided I wanted to have something that says a prefab as AWS script, so you don't have to do that. The only requirement you have is AWS prefab. So again, this is Grumpy Flappy. We're going to run it, and I'm going to explain as I run it kind of what's going on behind the scenes, and then we're going to go to the dashboard and actually look at that. So if I hit run here, we're going to maximize and play, and I'm just going to simply run in the editor because it's up, makes it easier. Here you go, Grumpy Flappy, right? So you have two options. So just following, again, the great advice Drew talked about, you can allow your users to first just play, creating an unauthenticated user there, letting them play, deciding whether or not they really like your game before they commit to registering or even attaching their social log on to you. So we obviously have a button that says, hey, I just want to play. But then I have a button that says, okay, I actually now trust you just a little bit that I'm going to actually register with you my game. So here I would put in, obviously, my name, that's not my name. Let's try that. Password, if I don't, you can put the little rules there, right? So I log in. I'm going to hit log in. And then if it likes me, it will bring up my game. Now, obviously, I want to score, and I suck at my own game. Isn't that bad? My son is clowning me. He's like, you can't play your game that you created. No, I can't. Just leave me alone. So as I pass the obstacles, my high score is not great. So if I pass the obstacles and kind of try not to die, which obviously is not working for me, it will record my high score as well. So let's see what the code looks like to do that. So the first thing here is you have your AWS prefab. Well, what I created then is an AWS Game Manager. That's going to contain the singleton that has all of the features I decided to add for this game. So let's actually look at the code. So here we have the AWS Game Manager. And so, I'll actually go to the menu first, because that's where we start. So you see, I'm using C#, so you obviously can use JavaScript and Bootstrap, but for Unity that we provide here, C# is your guy. So I simply put the namespaces in for AWS. No big deal. You guys are familiar with that. And I have a method in my singleton that's called AWS init. Once AWS init runs, so I did the good try-catch there, exception handling, it's going to give me back the sync manager and the Cognito credentials because that's what I'm using. And I want to sync those data sets to get my profile name as well as some other information. So this is the sync that he was talking about that's so great. And it's really simplistic to do. So once I got those back, it'll check for that data set. Again, following the steps that Drew talked about, opening or creating a data set. I have some default values called, game data set, so it pulls that back. If it finds me in my username, then the next time I come in and play, it will put my name there. So that's pretty simplistic. So let's look at the actual AWS code. The AWS code is really simplistic. All I'm doing is literally Cognito credentials, one line here. New credentials, I'm passing in my ID pool. That's the pool that once you create it, gives you that little weird looking number there. You got to take that. That's my identity pool, and then the region. And if you want to, these are just, again, I'm a lazy typist, as most developers are. So I just put this in a strut just so it would be easy for me as I change it in testing. No big deal, right? So once I do that, I'm raring to go. Once they want to change identities, now I have this in here just for me to test, but let's say they now trust you as we went through, and now they want to, hey, I will log in with Facebook with you. Then it will track the fact that, okay, this person is now merging over to Facebook. This is still, we want to keep their data in their data sets because they don't want to lose that great high score. It'll actually do this behind the scenes for you. This event that I put in is just for me. If you want to notify the user or say something like, hey, you got the green light, you're good, I've now tied your logins together, you're great. So at this point, I am ready to go. When I go back into the Unity menu manager, the only thing I've really done here is do a few callbacks. So you'll see I have an event handler. So, hey, is my sync successful? Do I have a conflict? Because I want to make sure I handle that. Which one wins? Is it the server or is it local? And then I start, and I'm ready. And I'm getting the identity back because, again, I'm going to show that when I play it again. Very simplistic. So let me go back to the slides. Maybe not. Haha. Okay. So what you saw at this point was I've created my identity pool. I've set up my mobile analytics app, as we talked about. We did the Unity we did the Unity 3D code to enable these. Again, very simplistic. Now, let's say I didn't add DynamoDB here, but I would be remiss if I didn't at least show you how simplistic it was to add that. And so we're going to walk through the steps really quickly. Of course, I'll show some code bites. I can create a DynamoDB table. I have 3 ways to create this. I can do it in the console. I can use code and do a create table. I also can use the Visual Studio with AWS for Visual Studio. I don't know if you can toolkit for Visual Studio. I'm not sure if you're familiar with this. So I'm going to switch back over really quickly to Visual Studio. I have this obviously loaded, and that link will get you there. But let's say as I'm developing and things of that nature, I just simply want to create things from AWS services without going back and forth in my browser. This is really convenient for me. So I could just literally go here to Dynamo. You see I already have one there, and create a table. And I determine which region that I want to do that in. So here I have East. But again, I can do all of this right here within Visual Studio while I'm building my Unity scripts, create my DynamoDB table, create my S3 bucket, etc. So I've done that. Switching back. Now I have my table done. I'm going to just create Grappy Flumpy. I said I was going to say that, didn't I? Okay, tongue twister, trying it over. Grumpy Flappy. What? Okay, I'm back. So at this point, all I need to do is create a DynamoDB client, and I'm off to the races. What about if I want to use that? So let's say I want to create a high score object, which is actually what I'm doing. And I want to use this data to create a leaderboard. So I can clown my friends about, I can't say how good I am. Okay, well, I can clown my friends about how good they are. Either way, this would be the code that I would add for that. So I'm going to create a class. He talked about the object mapper. If you've used any of the Hibernator things he talked about, this just looks familiar here. If you use JSON.NET, if you're a .NET person, you're familiar with this. So I create a class. It's going to be called High Score. I'm going to save that record, and the way I save that record is simply passing in, once I've generated a high score class, passing in that class with a call that says save my async. I'm using async await, the sync methodology. It gives me a callback and the void response result. And if there's an error, obviously you want to display it or you want to do something there. Very simple. I'm done. The next thing here I want to show you, if my mouse would cooperate. All right. So what if I want to add simple storage? Same story as before, nothing changes here. I create my S3 bucket. Notice I have a little thing there, set permissions. Permissions are your friend. I have been really frustrated going through code and realized, oh, I didn't give any permissions to the bucket. That could be why the code isn't working. You can either create this in code, again, using put bucket or put bucket request. And then finally, you create an S3 transfer manager, and you are done. Let's say I want to download an object because people are getting those cool badges to that because they have bragging rights, so they've done so well. That is the code to do that. Simply, I would do a get object request. Again, this is using the transfer manager, so all the goodness of the transfer efficiencies that Drew talked about is there for you already. All you have to do is worry about getting the object to you. And then if I wanted to upload an object, you see it here, I simply would do a new file stream, and I'm ready to go. So we talked about a lot of things. So I would be remiss if I didn't end this by at least giving you some resources. Again, this will be made available. So you have the mobile blog, the SDK, all the things we talked about. It's right here for you. Here are the resources to get to those. And of course, we have great documentation in the developer guides. I am finished, so please fill out a feedback survey to say how we did so we can make sure we do the right things for you guys. Have a great one.